Let's take a look at the quotient rule. The quotient rule. The quotient rule concerns differentiating a quotient, i.e. when you divide one function by another and ask, what is the derivative of this fraction? It can be stated as the derivative of f of x over g of x is equal to the derivative of f of x times g of x minus f of x times the derivative of g of x. And then we divide all of this by g of x squared in the bottom. So let's take a look at an example. Let's find the derivative of y equals 5x minus 2 over x squared plus 1. How are we going to do this? Well, we'll use the quotient rule. We'll take the derivative of the top, which is going to be 5. So let's just write everything out in full detail. And then let's use brackets here to highlight the distinction. Beautiful, and now we differentiate. We see it's 5 times x squared plus 1 minus 5x minus 2 times 2x all over x squared plus 1 squared. It's often not necessary to simplify. And this will be our final answer. Let's take a look at another one. This one I rather like because it shows us how to derive the derivative of tangent in case we ever forget it. So let's find the derivative of f of x equals tangent of x. So recall that tangent of x can be written as sine of x over cosine of x, and thus the derivative of tangent of x is really the derivative of this quotient and now we apply the quotient rule here. We square the bottom. Now recall the derivative of sine x is cosine x, so that this version turns into cosine squared x, and this one turns into plus sine squared x because the derivative of cosine x is minus sine x, and minus combine to make positive. And now further recall that that's cosine squared x plus sine squared x. This is a familiar trigonometric identity, and the top here will be 1. And now this turns into secant squared of x. So therefore, the derivative of tangent of x is secant squared of x. So now we have a way to derive this familiar formula in case you ever forget it.